Okay, today we're going to take a look at some complicated problems using nth roots and rational exponents, otherwise known as fractional exponents. Let's go. The first thing to notice is that both of our roots are to the same power, right? The fifth root, the fifth root. That's good. That means that probably we'll be able to condense this. Our next hint, this is the fifth root of 7. This is not going to reduce any further. So I'm going to take a big old guess and say that 7 is a factor of 224. Well, let's check that out. 7 goes into 224 32 times. Now, this is a fifth root. 32 can be factored out into 2 times 2 times 2 times 2 times 2. If you didn't know that, you'd do it more slowly and go 2 and 16, which is 2 and 8, dot, dot, dot. But so that rewrites as 2 to the fifth. So let's put that all under that square root sign instead of that 224. 2 to the fifth times 7. Now, if you watched my earlier video about the properties of nth roots, and if you haven't, go ahead and pause now and take a look there, then you recognize that the nth root of two things multiplied can be separated out into the fifth root of one of those things times the fifth root of the other of those things. And the fifth root of something to the fifth is just the thing itself, right? 5 2's multiplied together under a fifth root become 1 2 on the outside. And so 2 times the fifth root of 7 is what our first term becomes, plus 3 times the fifth root of 7. Now, here's the magic. This is what I call cow math. The fifth root of 7 and the fifth root of 7, those are the same quantity. So this is like saying 2 cows plus 3 cows, which would be how many cows? 5, that's right. And what was a cow in this case? It was a fifth root of 7. And that is our final answer, 5 fifth roots of 7. Next problem. The sixth root of g to the sixth times h divided by h to the seventh. So the trick of these things always is, what do I do first? So one possibility, you see a sixth root of g to the sixth, we know that eventually is going to turn into just g. So we could separate it and make it the sixth root of g to the sixth times the sixth root of h divided by the sixth root of h to the seventh. But before we do that, I think there's something sleeker we could do, which is this. H is being divided by h to the seventh. And don't forget our MAD spam acronym. If you've not seen this, go check out this video. But when we divide, we subtract the exponents. And then the other thing not to forget is h is really h to the 1. That's helpful in figuring out what to subtract. So division means subtraction. We have h to the 1 minus 7 or negative 6. And h to the negative 6, you'll remember your exponents. A negative means 1 over the positive version. So that would be g to the 6 over h to the 6. And now would be a brilliant time to remember. If you have the big old nth root of a fraction, you can make it the nth root of the top divided by the nth root of the bottom. So the sixth root of g to the sixth over the sixth root of h to the sixth, which is just g over h. Okay, one more. The third root of w times the square root of w to the fifth divided by the square root of 25w to the 16th. Where do we start? I want to start with the bottom because I see that both 25 and 16 will have square roots. So I'm going to start by separating those. Square root of 25, that's 5. Now, I want to show you a little hack for how to avoid getting this wrong. It would be really easy to look at this and go, well, the square root of 16 is 4. So the square root of w to the 16 must be w to the 4. That is incorrect. Here's why. Square root has an implied 2 as the power of its root. And then if you'll recall, a root and an exponent. The root is the denominator of the fractional exponent, and the exponent would be the numerator of the fractional exponent. So if I take this and don't write it as a root, but write it as an exponent, a rational exponent, it would look like this. W to the 16 over 2. That's the power of our root. That was our exponent. And you can see that 16 over 2 is not in fact 4, it is 8. And so our denominator is 5 times w to the 8th. Now, this is a third root. This is a square root. I cannot do anything to combine them like that. I am going to make those exponents rational exponents, fractional exponents. So remember, my w, that has an implied 1. And so if this is my denominator and this is my numerator, then the fractional version of this would be w to the 1/3. Okay, take a minute. What will the fractional version of this be? Don't forget, what's the implied thing there if there's nothing there? That is correct. W to the 5/2. Now, what's our mad spam tell us? When you multiply, you add the exponents. So this becomes w to the 1/3 plus 5/2. I need a common denominator. Everybody take a second and meet me there. Is that what everybody got? Excellent. Let's add those. Everybody still there? Excellent. Now, let's write this not as an improper fraction, but as a mixed number. Did everybody get w to the 2 5/6? Excellent. So then let's remember that now we go in the opposite direction. This is 2 plus 5/6, right? 2 and 5/6, which means I can spread this out and make it w squared times w to the 5/6, or I can finish it up in the following way. W squared times the 6th root of w to the 5th all over 5 times w to the 8th. And then my final step would be my w squared cancels with my w to the 8th. When I divide, I subtract. So first I would subtract up and get w to the -6, and then I would take that negative and bring it down to the bottom 1 over, and that would be my final answer. Now, depending on what your teacher wants, he might want you to do this root thing. She might want you to leave it as w to the 5/6. The point is we do not have any roots on the bottom, and stay tuned for some videos that will show you what to do if you do have roots on the bottom, how to get them out of the bottom of your fractions. All right, meanwhile, go ahead and check out my other videos on this subject. Leave any monster problems that you're wrestling with nth roots and rational exponents, and I'll make a video showing you how to solve them. Consider subscribing to my channel so you know when I put out a new video, and as always, keep on mathing.